All right, y'all, so that first video covers everything that we needed to. I do want to have like a little supplemental video to talk about some things that are maybe more specific to our class. And the first part of the first thing I want to kind of touch in a little bit more with is this right here, like these types of problems. Okay, so when I see this type of problem, right, where you've got like angles all over, you've got some filled in, some not, a little bit funky with how it's set up. First of all, I just want to talk about how I would approach this. Okay, so we know a few things about lines and angles and triangles now. Okay, and the first is one of the kind of pieces that you'll use a lot probably here is the fact that triangles angles add up to 180 degrees. Okay, so when I see something like this, right, where you've got triangles and you know some of the angles and you don't know some of the angles and different things like that, that's definitely a property that you want to keep in mind. Okay, so that's one thing to remember there. Another thing to remember is what we know about vertical angles. Okay, remember what we know about vertical angles is we know that they are congruent. Okay, and again, just what vertical angles look like. I always draw an intersection, and then I like to personally label my angles with a little symbol, so I know that they're the same, right? So these two angles will be the same. Okay, they're formed by an intersection. Okay, so anytime you have an intersection of two different lines, you're going to have one pair of vertical angles and then a second pair of vertical angles. Okay, and you'll see that a few times on this problem. So for example, you now know, okay, that 36, right, is this angle right there, that piece right there. Okay, so now you got to kind of fill in what some of those other ones are, and maybe another place to start is 118 and this right here. Well, that's another option. Okay, let's go ahead and talk about that option. We've got linear pairs. We can't forget about that. Okay, which add up to 180, and again, those are where you kind of draw a line and then they intersect here and here, right? So like you've got the reason why it's called linear pair, right, is because you've got two angles that lie on one line. Okay, so don't forget these two also add up to 180. So those are some kind of tools that you can use to kind of complete all this stuff. And then don't forget, right, like for example here with the 74 and 65, technically these three don't form a linear pair, but they do add up to 180, right? So even if you have three, right, because I've got this straight line, right here, that's 65, so 65 plus 70 plus angle 4, whatever that is, would add up to 180. Okay, so I just kind of wanted to give you some tools to approach this problem. I'm not actually going to do it, but I just want to remind you of some different things that would get you kick-started. This is actually a problem on your assignment. So I don't want to do the entire thing for you, but I did want to kind of mention some strategies before you just kind of go in blindly. Okay, and the second thing I want to talk about is this. Get rid of that. Is these types of problems. So let's say I had something like this, okay? And let's zoom in a little bit here. Okay, let's say I had something like this. So in the video, we talk about like the different types of triangles, classifying triangles based on the types of sides they have, right? You either have an isosceles. Let's go ahead and talk about our options. So I'm labeling by classifying by sides. Classify by sides. Okay, so you either have a scalene, so all different sides, all different lengths, I guess I should say, all different lengths. Okay, then you've got isosceles, okay, which is two congruent lengths for the sides. And then you've got an equilateral, which is all three congruent lengths. Okay, so those are your options. Okay, either either they're all different, you have two that are the same, or you have three that are the same. Okay, so if I'm looking at this one right here, okay, I noticed right off the bat, okay, that I have these. Okay, now this symbol right here, okay, we know to be congruent. Okay, so let's just see how many different types we have that are the same. Well, we've got 1, 2. Okay, so this is an isosceles triangle. This is an isosceles triangle. Okay, we know this one's not the same because we don't have those tick marks. Okay, so it's an isosceles triangle, and how we approach this is if we're trying to solve for x here, well, we know that we have two congruent lengths. So let's use the pieces of information that we know, right, which is that these two are the same length. Okay, therefore, the expressions also have to be the same. Okay, so the algebra from here, right, is just going to be saying that these two are the same. And again, the reason we know that is because it has that tick mark. They're labeled like that. Okay, they have that tick mark in here, which tells me that they're congruent. Okay, so that's why we can say that 20x minus 5 is equal to 8x plus 43. Okay, so you've got your classic algebra problem, right? I like to start off with my x's first, so I'm going to get rid of this 8x, right? And only because this 8x is less than the 20x. Okay, so I've got a minus 8x minus 8x. So over here I've got 12x minus 5 is equal to 43. Okay, now I want to get this by itself. Okay, so I'll add 5, and I've got 12x is equal to 48. Last step, divide by 12. Okay, so we got x is equal to 4. Okay, and if that's what all the problem is asking for, then you're done. So it just depends, right? Sometimes it just asks for x. Sometimes it might ask for this entire thing. Don't forget that if it asks for this entire thing, you just got to take that x and plug it back in, right? So you would have 20 times 4 and then subtract 5. Okay, keep that in mind. But that is solving for x there when you know two sides are the same. Now, somewhat of a similar situation on the back. All right. This time, though, we have 3 tick marks. Okay, so when you have 3 tick marks, well, that means all your sides are the same, so this is an equilateral triangle. Equilateral triangle, which means all your sides are the same, right? And again, the reason we know is because of the 3 tick marks. Okay, so on this one, you can actually set any 2 of these equal to each other, and you should get the same answer. Okay, so on this one, I mean, pick any 2, right? We could sit here and we can do these 2, or we can do, it doesn't matter, okay? You're going to get the same answer regardless. I'm just personally going to pick these 2, no real reason. But we can go ahead and say now that 2y plus 10 is equal to y plus 15. And again, we know this because of the tick marks, okay? And we could have used this one, we could have incorporated that 4y if we wanted to as well. But anyways, minus y, minus y, so I've got y plus 10. All right, is equal to 15, and then subtract 10 on both sides, so I've got y is equal to 5. Okay, so that's your answer on that one. Okay, so that's how we would kind of solve with an equilateral triangle when we know all the sides are the same, and we have we have an expression, right, with our different sides. Okay, I just wanted to clarify those 2 things, but that does cover everything for our topic. Hopefully you guys like that other video. I personally love when they have all those visuals and different things like that. That is something that you can't do with pen and paper, right? So hopefully you guys enjoyed that. That's all I got today. You guys take care.